Hi, my name is Shufan Kang. Uh, Now I will demonstrate you the how the challenge assignment one works from the ECE431. First, I will explain you how my code works. He from main here, the first function is called init GPIOs. This is the actual function for init GPIOs. First part, I set the pin 1.1 as the input pin, which with pulling up registers, and then I enable the interrupt, clear the flag, and then I set the pin 2.0, which is red LED, as output pin, and the output init to low, and the same here to the red LED as output pin and set it to low. And then I need the time system. First, I initialize the system reference clock to 128 kHz. Then I set the A clock to 128 kHz. Then I set the SM clock divided by 4 to 32 kHz. And then I configure the time A0 to continuous mode. Here is the detailed configuration. I select the time A to A clock, which is 128 kHz, and I divide it by 1. So the time A so the time A will have a 0.5 second per interrupt, and I enable it. Here I then enable the time A0 interrupt and start the time A0 counter. And then I enable all interrupts. Here I init the watchdog timer, select the clock source with the SM clock, and have a iteration of 32K. Since the SM clock is 32 kHz and the watchdog timer is 32K, so which means 1 second the watchdog timer will expire. Then I start the watchdog timer here. For here, I will turn the red LED on and do a 1 second delay and turn the red LED off. Here is the timer A0 interrupt service routine. First, I clear the watchdog timer, which means every 0.5 second the watchdog timer will clear, so it will never expire. And clear the flag and count those two counter up. And then here is the GPIO's interrupt service routine. Here, these two statements indicate whether the switch 1 was pressed. If the switch 1 was pressed, it will disable the timer A0 interrupt service routine. So the watchdog timer will never be cleared, so it will have a system reset. In the main while loop, first I clear the flash counter, so it will come back once every minute. First, I will perform erase memory. In this erase memory function, it first unprotect the whole flash main memory bank 1 with all sectors, and then perform a mass erase. This what this code block does. This code block will verify byte by byte to check if the data in memory was successfully erased, which means all the data in memory will be FF in hex. If the data in memory is not equal to FF in hex, which means I did not successfully erase all the memory, it will return 1. And in this while loop, if it returns 1, it will continue do again until it succeeds, which returns 0. Here in the program memory function, first I divide the 128 kilobytes into 32 sector. Each is 4096 bytes. In this function will copy the data from the source to the destination, which is the starting address of the bank 1. And here I declared a data array, which is no initial value, so it's all 0. And I program the zeros into bank 1. This loop will check byte by byte to check if the data in memory have same value as the data that I write into. And if it's not equal, I will return 0. So which is same thing as the erase memory. After these two action was succeed, I will turn on green LED for 1 second, which is same as the red LED, and stay here until 1 minute end. Let's debug this code. The two main important things, which is the erase and program, I will set 2 breakpoints in each function. Sorry, I put too many interrupts. And let's run the code. So here, I stopped the code here, so it will already perform the mass erase. So let's check the address. You can see here all the memory was erased to FF in hex. And this in here, I will check each data in memory to see if it's equal to 00, is equal to FF in hex. And you can see here, I will go through all the address in the main memory until it arrived at the end of bank 1. And now let's remove this breakpoint and continue. So it goes into the program memory part. Since it's already around this function, so the first sector of the main memory was erased, so it's is programmed. So let's see here. So it's all programmed to 0. And this, let's see how this loop works. So here I will get every bit in the address which starts from the start of the bank 1, and check if their value is same as the data. So let's go through. So it will go through all the address. So let's remove this breakpoint. And actually now I will show you how this code works in the board. Here, let's start the code. Hit start. Here the red LED turns on 1 second, so which means the system starts. And because I said the system clock was a little bit slow, so it takes a long time to erase and program 128K. So I said the green LED turned on, so which means the memory would be successfully programmed. And let's stay for 1 minute, see if the green LED will turn on again. Yeah, that's the green LED turns on. It's actually exactly 1 minute. So let's see what if I press the switch 1. You can see here, the red LED turns on about 1 second, so it indicates the watchdog timer was expired and the system restarts. And I can do it again. It turns on. And I also want to show you the green LED will again turns on to show that I can still program the erase and program that flash memory. Yeah, you can see here, and I can press the switch to expire it. That's all about it. Thank you for watching.